Tonight's lesson is on polynomial inequalities. It's going to feel like review. We start with number 1, which is quadratic inequality, and the steps are here. You need to set the inequality less than 0, and then you factor. Then you find the zeros by setting each of the factors equal to 0. You're just collecting the zeros, so when you draw a number line, you can put the zeros on there. You decide whether to include the zeros or not, and then you check each interval by finding a test point and plugging it in, or you could graph the polynomial over that x-axis. Once you've done all that, you want to then look at the inequality sign and determine which values are going to make a true statement. Number 2 is a quadratic. Number 3 is new. It's not quadratic. It's a polynomial. It's degree 3, but it's already factored. So you don't have to multiply anything out. You've already got it in factored form. You're just going to find the zeros and then graph your number line. Number 4 is also already factored, but it's got a multiplicity of 2. We'll talk about that. And then I put number 5 in there just to remind you that this is not factored. These pluses mean that you're going to have to multiply all these terms out and then add like terms and then factor. Okay, so example 2, we have 2x squared minus x is less than 15. First thing we want to do is move that 15 over. So it's minus 15. Since it's a 2, since it's quadratic, we can factor in 2 binomials. And since it's a 2, you know it's going to have to be 2x and x, because this 2 times 1 is the only choice you have. And then the factors of 15, 1 and 15, 3 and 5. And now since we have a 2 in the front, we have to look at the outer and inner terms. The outer and inner terms need to subtract to be 1. So I'm going to put 3 in the second binomial and 5 in the first one, and then that's my outer terms. That gives me 6x, and the inner terms give me 5x, and they do subtract to be 1. So I know I have the right numbers. And then I do the sign. So I want it to be a negative 1, which means my 6x needs to be negative and my 5x needs to be positive. You still subtract. That gives you negative 1x, and that tells me the minus goes with the 3 and the plus goes with the 5. So now I have it factored, and I'm going to find my zeros. By setting each factor equal to 0. You get 2x equals negative 5, and x is equal to negative 5 over 2, and then x is 3. So those are my zeros. Once you have your zeros, then you have your number line, and you want to make sure you put your numbers in the order that from left to right, negative 5 halves, and then 3. These are your 3 intervals, and you don't want to include the zeros because it says less than 0, so you're going to have an open circle. And now it's time to pick numbers that represent every x value in each region. So I pick negative 4. If I put negative 4 in the first binomial, I get negative 3 times a negative 7. So the negative times a negative is a positive. If I pick 0 in the middle region, it's going to give me a positive times a negative is a negative. And if I pick 4, I get a positive times a positive is positive. So now I know the behavior of every number, and I want only the x values who give me y values that are less than 0. So that's negative region. So the answer is parentheses, negative 5 halves, comma 3, close parentheses. Example 2 is another quadratic that'll factor. 3 is prime, so we know it's 3x and x. We want to check the factors of 20. That's 1 and 20, 2 and 10, and 4 and 5. And we want to figure out which of those work together with that 3 to subtract to give you 7. So my outer terms I've marked and my inner terms I've marked, and again you want to try the ones closer together. So let's try 5 and then 4, and sure enough 3x times 4 is 12x, and 5 times x is 5x, and they subtract to be 7. And then I look and see I want it to be a positive 7. So that would mean my 12x needs to be positive and my 5x needs to be negative, which means my 5 is negative and my 4 is positive. Now I'm going to find the zeros. And I get x is 5/3 and x is negative 4 are my zeros. And now I'm ready to draw my number line and make sure I put my numbers in the right order from least to greatest. So negative 4 and 5/3. This time we're going to be colored in circles because it says greater than or equal to. And I'm going to create a region, 3 regions, and put test numbers in. So if I try negative 5 and put it in my first binomial, I get a negative. In my second binomial, I get a negative, and so I get a positive. Second region will be a negative, and the third region is going to be a positive. And you can see the signs alternate. And we want the answers to be the x values that give me positive y values, so that's the region from negative infinity to negative 4 and the region from 5/3 to infinity. So if I put the answer in interval notation, that's parentheses, negative infinity, negative 4, bracket, union, bracket, 5/3, comma, infinity, parentheses. Alright, so next we have something different, a polynomial. Because it's degree 3, it's not quadratic anymore, but it's already factored, so we're trying to help you here. You would not want to multiply it out. If it's in factored form, you have the zeros. So you just want to list the zeros, which should be easy to do with these linear factors. The zeros are 4, negative 3, and 1. And so you're going to draw a number line. Take care to put numbers in the right order, and take care to pick numbers that represent the region. So we want open holes on the zeros since it says greater than 0. And we're going to put test values in. To the left of negative 3 is like negative 4, not negative 2. Negative 4, and if we put negative 4 in here, I get a negative 8, which is a negative, times a negative 1, which is a negative, times another negative 5, which is a negative, times a negative, times a negative, which is a negative, because if you just think of it, if you have odd number of negatives, then the final answer is going to be negative. And then if we put in 0 into each of the binomials, you get a negative times a positive times a negative, which is a positive because you have 2 negatives this time. So 2 negatives turn to a positive. And then between 1 and 4, we can check 2. That gives you a negative. And if you check 5, you're going to get a positive times a positive times a positive is a negative. Notice that the signs do alternate here. We want a greater than 0, so we want all the x values that make pluses make positive y values, so you shade the pluses. That gives you parentheses negative 3, comma 1 parentheses union 4, comma infinity. So just be sure you don't do anything careless. Negative numbers, negative 4 is smaller than negative 3. And then again, you should have not been surprised that you have alternating signs here. The other way you could do this is you could graph it. If you get the leading term, 1x cubed, and know the end behavior is down, up, you can start here down and go straight through the 0 of negative 3, turn around, go straight through the 0 at negative 1, or 1, excuse me, and straight through the 0 at 4, and you end up down, up. And greater than 0 means the places where the function is above the x-axis, which is exactly where we shaded. Okay, so example 4, we finally have something a little different. Notice the exponent 2 here. It's already factored, so we don't have to multiply it out. We just need the zeros, and the zeros occur at 3 and at -5. But the 3 has a multiplicity of 2, so we're going to see what happens. So make sure you put the zeros in the right order. -5 goes to the left and 3 to the right. It's greater than 0, so we leave those holes open, colored. We don't color them in. We'll put some test values in. Let's put -7 in. Now when you put -7 in there, you get -10, right? But you square that, and so that becomes a positive. Anytime one of your binomials is squared, it's going to turn it positive. And if you put -7 in the second one, you get a negative. So a positive times a negative is a negative. Again, that square will turn that -10 to a positive 100. So that's the plus. And then the -7 plus 5 is -2. That's the negative, and positive times a negative is a negative. Try 0. Again, when you put 0 in, 0 minus 3 is -3, but you square it, and that becomes a positive. And then you put 0 in, you get a positive, so you get a positive. Now watch what happens when you put a test number in after 3. You get 4. Let's test 4. 4 minus 3 is 1. 1 squared is positive. 4 plus 5 is positive. You get a positive. And so you can see for the first time we do not have alternating signs. And that is because the 3 had a multiplicity of 2. See the square there? Okay, so if you were to graph it, it would go straight through the 0 at -5, right? It'd turn around, but when it got to 3, it would bounce back up. So you can see that the graph is above the x-axis from -5 to 3 and from 3 to 4. So that's why that's happening. Now to finish this problem, we want greater than 0. So we're going to shade the regions that are above the x-axis, or where you see the pluses. And so the solution would be -5, 3 parentheses union 3 to infinity. So because we can't include the 3 because 3 equals 0, gives you a value of 0. Okay, now I put example 5 in here to try to anticipate some errors. This looks like it might be factored. You got some binomials, but the thing you want to see is the pluses. So because we have the pluses, this isn't factored, and so we have to multiply everything out and then turn around and add like terms. So I'm going to square double square x minus 2 squared and get x squared minus 4x plus 4, then plus 9, and then less than. I'm going to distribute the -2, which gives me -2x squared plus 28, and then minus 19x. So now I have everything multiplied out, and now what I'm going to do is add like terms on the left, and then that gives me, I want to put it in descending order, so it gives me x squared, and then -3x and -4x is -7x because the signs are the same, and 4 and 9 is 13. Now I need to move everything to the left side, so I've got x squared minus 7x plus 13, just double checking my work, and then I need to move the minus 2x over, and the 28 over, and the minus 19 over. And when I move something over the inequality sign or the equal sign, it changes sign, so that's going to make it plus 2x minus 28 plus 19x. And now I'm going to add like terms again and get 3x squared, and then minus 7x plus 19x is positive 12x, and 13 minus 28 is -5. And then I notice that there's a 3 that divides into all 3 terms. So I'm going to divide out the 3, which is legal. And it's not a negative, so I don't have to worry about the sign changing. So that's going to reduce this function to x squared plus 4x minus 5, and it's less than 0, and that factors. And so I'm going to factor it into x plus 5x minus 1 is less than 0. My zeros are -5 and 1. I'm going to graph it. Leave those zeros open circles since it's not equal to 0. I'm checking -6 as my test number. I get a positive, putting in 0 as my test number, getting a negative, putting in 2 as my test number. And now that you know why things alternate or don't alternate, you can go a little faster. There were no double roots, no multiplicities of 2, no bounces. So you got a -5, 1. There's the multiplicity 2. And that's why you had a bounce, and that's why the signs didn't alternate. And then I'm just kind of reminding you, why did we have to do all this for example 5? Because of the pluses. That's not factored. Things have to be separated by multiplication. So make sure that you notice that. And you have to add your like terms. Okay, now what we're going to do, we're going to go to page 113 and do those 5 problems there. You really should stop the recording right here and just use this to check your work.